got it loaded. Time in seconds and activity in mega equals. What's wrong?
No, she's making fun of me.
What is she saying about you? Poor Andek. What is she saying, Andek?
Minor.
Why did I say that?
Yeah, she's just like randomly
Why?
saying minor.
Are you a minor?
Yes.
Okay,
Because
well.
he was on his phone.
Yeah, but we said it in a discriminatory way.
Yeah, don't discriminate against him because he's a minor. Anyways, how old are you?
20.
Okay, nearly a minor.
No.
Yeah. Well, if you were in America, you wouldn't be old enough to buy beer. So, you're a half minor.
I
Yeah.
don't drink anyway.
I know. You have to be 21 in America.
Oh,
Surprising, isn't it?
surprise.
You can buy a gun when you're 18. But you can't buy beer when you're 18.
You can buy a gun when you're 18.
Yeah,
You
a
can
gun.
okay.
Yeah, a gun, yeah.
I think my gun.
But you can use gun to buy beer.
True. No, they let you buy gum at any age.
That's why I was confused.
Yeah.
To borrow beer.
Yes. So when you're 18, you can buy a weapon, you can join the army, you can vote, you can drive, but they won't let you buy beer, which is just, to me, quite amazing.
Why?
Because they think you're not old enough. You know? Like, yeah, but you think they're old enough to join the army, buy weapons, drive a car, but not drink beer. Doesn't make sense. I think it's because you remember, I don't know if you know this, but remember America, I don't know if you learned this, maybe about 100 years ago, they tried to ban alcohol. You know about this? Yeah, so kind of America kind of has a weird relationship with alcohol. You know?
A lot of people getting rich because of this.
A lot of people what?
Rich.
Rich?
Because
Oh yeah, correct. Yeah. Rich. Yeah. Lots of crime. Yeah. So anyways, they have a weird relationship. It's not quite Muslim, it's more like, what's the word?
Americans.
Well, yeah, true. Do you know, I don't know if you know this word, Puritan? Do you know this word? It's like the Western version of people who live very strict lives, if that makes sense. Do you know, so they don't smoke, they don't drink, you know, this kind of thing. Yeah. So, you know this word?
Like Muslim.
Yeah.
They don't drink.
Well, Muslims smoke.
Smoke.
You do, yeah.
It's still not allowed in the religion to smoke.
Muslims? Really?
Yeah.
How come I see all of my students smoking all the time?
Not religious.
Oh, I see. Are you sure?
Yeah, it's a minor sin.
Wow, I thought it was okay. No, it's not okay.
Still a sin.
Is it one of those things that different people have different opinions on? No,
this is
it's
what
fairly clear.
they don't really.
It's, okay.
So anything that harms your body is.
Ah!
You do it willingly.
Smoking definitely harms your body, there's no doubt about that.
Smoking, tattoo, and
Tattoos, yeah. And probably drugs and
yeah,
things like
that's
this.
definitely.
That stuff like that. Yeah. Oh, I didn't realise that, Siba. So it's not the ban is for particular things. The ban is on things that harm your body. Is that the idea?
Intentionally.
Yeah. Okay. So well, I don't know if you know this, but does it say in the Quran or wherever? It's like don't drink this, don't smoke this.
Yeah.
Yeah. Okay. And does it say don't smoke or just don't do things that harm your body?
So smoking and drinking, they fall under the same category. So
Oh,
anything-
really?
Yeah, anything that alters with your brain, so they're the same.
That is interesting. So really, I shouldn't be seeing my science students out having cigarettes then.
But it's a minor sin, like it's not big.
Okay.
Well, that's what they say. But
Okay, it won't get you into lots of trouble then.
I mean,
Yeah.
I haven't read his example, but he says was.
Yeah, if you die of smoking in Islam, it's considered suicide.
Is it really?
And suicide, you don't
If you
go
get
down
like lung cancer or something.
because of it, yeah, you
is very interesting. I'll have to remember that next time somebody steps out of my class to have a cigarette. That is very interesting. Oh, so that's not the time. That's should be over there. Okay, so for this lesson, am I recording it? Yes, okay. For this lesson, it is the graph. You were in this lesson, Siva? Or you weren't? Were you in this one or not? No. You were, and you were. Oh, because this was the second hour of the double class, yeah. What's after 2.1? 1.78, 1.49, 1.2. Uh-oh, something's gone off here. Oh, I see what it is. I'm off by... I shouldn't start at 0 here, should I? Right. Now, those two guys might know. The first question here is to graph this in an appropriate manner, which means make a suitable graph. Now, you might think the suitable graph is just time and activity, but it's not. Do you remember Andek, the thing here that's important?
Straight line.
Yeah, but how do you get the straight line?
It's because of the tangent, the ln,
The log.
the log of.
Yeah, so what, in other words, what should I do next?
Find the logs of value.
That's it, yeah. Find the logs of which?
The a over.
That's it. So the next column is log activity in mega equals. So that's ln that. Now I'll just do 2 decimal places maybe. Yeah. Yeah. So did you say you watched this video, Stephen? What we do is we put the time on the x-axis, and then we put log activity on the y-axis, and we don't really care about the activity. Okay. So you might need to copy these values down because we're going to make the graph in a second. So I'll just put boxes around this one if I know how to. Do I know how to? Do I know how? I don't think I know how. There, I made it a funny colour. What's that?
No, I couldn't stop thinking about mishearing gum.
Yeah, totally wrong. Okay, can you copy that table down and then we'll make the graph now in a second. Got it? Yeah. So, nearly, okay. Yeah. Let's make our graph now. Insert chart. Scatter. Now you should pay close attention because you'll need to do this for your lab report, you know. Next, no, back. Oh, hang on, let me cancel that, sorry, cancel. I should highlight the data first. Right, time and activity. Okay, now let's try again. Insert chart, scatter. Next. Right, the title is log activity against, I'll put it in words, log activity against time. The x-axis is time in seconds and the y-axis is log activity in log megabecquerels. There we go, and that's the graph. Now let me just add in the vertical lines too to make it look a bit nicer. And then what we normally do too is we can draw in the trend line. But before I draw it in, I'm going to ask you guys, using this graph, calculate the slope. So remember, slope is the y over the x, the rise over the run. So if you look at this graph, you could draw, can you see here? You can draw a big triangle here. So how big is the base? 10. And how big is the height? It's about maybe like 1.6, something like that, yeah. So can you calculate the slope? Yeah, give me the slope.
The slope is the lambda, right?
It's minus the lambda, yeah. Minus 1.8 or 0.18? I think your answer sounds too big. What did you type in on your calculator? Okay. What did you get, Andek?
I'm not really sure.
No, tell me what you got, it's okay.
It's very direct, 0.161.
0.161 minus 0.161 because it's going down, okay? That's reasonable. What did you get, Stephen?
-0.56.
What? What are you typing in? What did you get, Chow?
Me?
Yeah.
Slope?
Yeah.
10.1.
What?
10.1.
Isn't it just squares over?
Yeah. It's just 1.6 over 10.
Yeah.
1.6 over 10?
Yeah.
Yeah, I got 0.16.
Ah, so this the triangle.
It's a triangle. Yeah. Come on. Yeah. Maybe I have to start beating you now or something. So,
0.06.
about 0.16, yeah. Now, if you actually, can you see here? You can have Excel calculate these things exactly. You can see it repeats 18181818. So the precise slope is minus 0.17. That's exactly what it is. Okay, and so that means, I guess, this number here is not 1.6, but it is actually 1.7. Okay, so if the slope is minus 0.17, then that means the lambda is 0.17 per seconds. Okay, so part B is the slope equals minus 0. What did I say?
1.6.
Well, yeah, we'll be a bit more precise. 17 per seconds. So then that means so lambda is 0.17 per second. Is that okay? Guys, did you draw this in your notebook?
Yeah.
You have the graph drawn? Wonderful. Chow? Draw the graph. Siva? Okay, if you two can draw the graph, you'll need it in your answer. This is the answer for A. Do you draw a nice graph?
Yeah.
Show me. How nice is it? It's nice. It's because you're a minor. You have better graphing powers.
Maybe.
True. True. Because it's not so long ago that you were colouring in school. Bad Stephen. Bad Stephen. Sorry, Amda. I couldn't resist.
I'm fine if it's coming from teachers, but from her, no.
Yeah.
Why?
Because,
It's harsher that way.
yeah.
You're very harsh, Siba.
Me?
You're very harsh.
Actually?
No. No. Have you guys all finished your university applications? Yeah?
Not all.
Not all, okay, but you put your choices in?
Yeah.
So you all have a good idea of what you need in physics?
Yeah.
What do you need?
See.
Okay.
B.
Whoa! You really need to put the foot down, you know? What do you need, Cho, for physics grade?
Pass.
Pass, okay. Still, you need to work to pass.
Actually, I don't need physics.
You don't need physics? You
I
sure?
I need physics score, but my subject have
No physics in it.
No physics in it.
Why, what's your subject?
Psychology.
Ah, yeah, okay. Yeah. What's your subject for
Mm.
next year?
Product design engineering, so.
Product design.
Yeah.
Yeah. Is that like industrial product design? Or
Yeah, something like that.
And Siva? What, I forgot, what did you say yours was? Biomedical. So if they only need a C in physics, does that mean they need a B in chemistry? They need a B in maths. They feel maths is the most important to have for bio. Okay. Okay. Well, that's probably good for you because maths is probably the subject you did best in your exam.
Chemistry.
You did better in chemistry than maths. Are you sure? That's amazing. That doesn't usually happen. How much better was the chemistry? What was the difference?
2 points.
No.
Oh,
Back,
what's on?
back to the answer.
Oh, here.
Thank you.
Okay, 2 points means it's nearly the same. All right, do you have this drawn?
Yep.
Yeah. Siba, you have this drawn? Yeah. Okay. C. What is the half-life? So how can I get the half-life here? How can I get the half-life? You have a formula for it. What is it? You know what it is. What's the formula? You have it. You told it to me earlier today. You gave it to me earlier today. No? One of the two of you did. I don't remember. Yeah.
Oh, and then 2 over lambda.
And then 2 over lambda, isn't it? Right. So what's that here, please?
minus because it's going
I got rid of it because the lambda is minus m, so the m is minus, so 2 minuses made this 8 plus here.
4.08.
4.08 seconds. Yeah. Is that okay? Yeah. D. What is n0? So n0 equals minus lambda a0. That equals minus 0.17. And what's a0? If you look at the question, you can tell me what a0 is.
Five.
Nearly. Look carefully. Is it 5?
5.00.
5.00 is the same as 5. Chow is not 100% right. What did he forget? Can anyone see?
And BP too.
Yeah, so it's not 5. What is it? Of what? 6. Mega. Alright, what's that, please? Oh, 2 mine. Huh? Flip. No, don't. Sorry, I wrote the formula down wrong. It's not. I wrote it backwards. It's a0 equals minus lambda n0. So that means 5 times 10 to the 6 equals minus 0. And there's a minus there. 17 n0. So the answer is n0 equals 5 times 10 to the 6 over 0.17. Two nine four one one. 764. 0.7. So 765. So that's 1, 2, 3, 4, 5, 6. So that's 29.4 times 10 to the 6.
Why is 5 or 10 to the 6?
Why 10 to the 6? Can you see here? Because these are megas. These are all megas. Mega is 10 to the 6. Yeah. Is that okay? Are you sure? Yes? E. What is the n when t is 11? So that means n equals n0 e minus lambda t. So that's equal to 29.4 times 10 to the 6 e power 0.173 times minus and 11 is here. So when you're ready, you can give me this answer. Five, 3, 8, 4. Oh, say again, 5?
4, 4, 3, 8, 4. Not 5. No 5.
Alright, hang on, let's just start again. Go.
4.
Yeah.
3, 8, 4.
Yeah.
1, 4.
Yeah.
5.22.
So 1, 2, 3, 4, 5, 6. So that's 4.38 times 10 to the 6.
Sorry.
Yeah.
Where is the minus 0.173 come from?
That is from here, the slope. So when you have this graph here, the lambda is equal to minus the slope. And it's roughly...
0.
Yeah. So we have our coursework 2 to write up, and then we have 5 worksheets left. So we're doing okay for time, because there's still like, what, 5 weeks left? 5, something like this. So I'll say we should definitely be finished at physics in 2 weeks. This will give us 3 weeks of revision. Yeah?
5 weeks left.
I think it's something like that, isn't it? Or is it 6 weeks?
I think 7.
Is it that many? Are you sure?
7.
What date do we finish on, Tommy?
29.
Okay, sorry, 29th. Oh, sorry, yeah. 1, 2, 3, 4, 5, 6, 7, 8.
7 weeks, yeah.
7 or 8? Because you have 1 week holiday somewhere in there, don't you?
Ah, yeah.
1, 2, 3, 4, 5, 6, 7, 8. So you have 8 weeks, but 1 week's a holiday, so that's 7 weeks. And then I don't know, sometimes in the last week there's like no classes because there's EAP exams and listening and or whatever the heck you do in EAP. So my point is, for me, I need to assume that I only have 6 full weeks, which is plenty of time, because like I said, we should be finished this book in 2 weeks. We'll probably spend 3 or 4 weeks on the coursework. Yeah, and then the revision will be maybe 3 weeks. 3 or 4 weeks.
If I want to pass physics, and which part I need to focus on, the easy part?
The most important thing is that you're practicing exam questions. It's the most important thing. And the second most important thing is, in the final exam, it will have a little bit more semester 2 than semester 1.
So more weekly questions.
More which one?
More recent questions.
Yeah, so in my opinion, the best, well, hang on, let me just finish this question, then we'll talk about exam strategy. So the last thing is, what is wrong with that graph? So if you look at the graph there, there's one tiny mistake in it, something that we don't quite like, or something.
It's curvy.
No, the curve is, well, true. No, I'm sorry, you're right. No, you're absolutely right. We tried to make straight line graphs, so here we should have used a log. That's one mistake. There's another small mistake too.
Time in here.
No, that's okay, there's no problem with that. Anything else?
You know why I explained it?
I know it has an XY. It says time. Yeah. Anything else? There's one thing. Can anyone see? Nobody can see? So look, what's the units there? Grams. And that's okay, except the way they write it, they put it in brackets. That's not how we type it. What should we have done? Or what should they have done? The slash. So they should have said strontium 90 slash grams, and it should be time slash years. Is that okay? Okay, let me just close this here. So if you want now, keep your notebooks open, because I just want to give you some things to be thinking about for your study. So my advice for this exam for section B, like my number 1 rule is, so this is Stephen's rule 1. Okay, Stephen's rule 1 is always do the atom question. That's the chapter we're doing, atoms. Always do the atom questions. Rule 1. Yeah. Rule 2. Never do the fields question for section B. Fields.
Fields.
Yeah. Fair enough. Rule 3. Always do the graph question. Yeah? And then, last guideline. Now, I'm going to give, okay, I know I say always do and never, but of course, you have to judge for yourself. But my experience is if students in the past followed these rules, some of them would have done better. You know? So, like, I think 2 years ago, I was talking to 2 of my students after the test, and I said, I saw you did the fields question. Why did you do the field questions? I told you in class never do the fields question. And both of them said, I don't know. I just looked at it. I just did it. It's like, why? Because the reason I'm telling you these rules is the atoms question, students always answer it best. The fields question, they always answer it worst. Okay? The graph question is a question that you can get easy marks in because they'll ask you just to make a graph and to calculate the slope and all this stuff. That's good. And my last guideline here is questions about the ideal gas law are usually quite good. Now the problem is sometimes that question is mixed with, you know, latent heat and heat capacity, which students sometimes do badly in. So the question is sometimes a mix of they do well in the ideal gas law part and then badly in the heat capacity part. The same kind of thing goes for mechanics. Sometimes it's an easy mechanics question, like, you know, 2 things collide or something like that. But then sometimes it's quite tricky, like, you know, something like a projectile. And again, the electricity is, I like electricity. I like the Kirchhoff questions, but sometimes students don't. Okay, so the other 3 topics, mechanics, materials, and electricity, you'll need to figure out yourself which one you feel you do best in. Okay, so what are the guidelines? Always do atoms, never do fields, and always do the graph. Okay. Now, there could be sometimes this is usually what happens, okay? So, you have 3 topics in semester 1 that you've done. You've done mechanics, materials, and electricity. And then in semester 2, you did waves, fields, yeah? And atoms is what we're doing now. So like I said, if you get an atom question, you should always do it. I think 2 years ago, there were 2 atom questions in section B. Section B, I think, is 5 questions. Okay? But 3 of them will be from semester 2, and 2 of them will be from semester 1. So what that means is, one of these 3 won't be in section B. The graph question could be in any of them. So for example, if the graph question was in atoms, they'd ask you to do something like log activity, you know. If it was in electricity, it might be they ask you to make a graph of this, you know. So the worst situation is if there's only one atoms question and the graph is in the atoms question, because then it means, kind of forces you to do something that maybe is a little bit harder. Like, consider something, which would you say is your best topic here? Mechanics, materials, electricity? Mechanics. So imagine the section B wasn't this, and it was materials, electricity, waves and field, and the graph question was in the atoms. So that means you do this question, you should try not to do this question, but you've already done the graph question, so that means you have to make a choice between materials, electricity and waves. Now that's up to you. Okay. I personally I like the waves because a lot of it can sometimes just be definitions, like what is a longitudinal wave, what is a transverse wave, what is resonance, you know. But sometimes the students don't like these questions, you know, with the waves and the pipes. Do you remember those? Yeah. I also like the electricity and the materials. The mechanics, sometimes it's good, but sometimes it's really bad. So I suppose my last rule is be careful with the mechanics question because it's really 50-50. Do you understand what I mean by that? Yeah. Like I'll give you an example. Okay. One year the mechanics question was about something like this car and this car, they crash and then they move off together. Easy, right? And then they'll ask you like, what's the kinetic energy? Easy, right? This is not so bad. But then another year the question was like this. And they asked you for what's this distance? Yeah? Do you see what I mean? So if you do the mechanics, just make sure before you started that you'll be able to finish it. Because you don't want to discover halfway through that you chose the wrong question. Yeah? Anyways, you'll get a better understanding when we start looking at section B's. You have no choice about section A, you have to answer everything. But section A is just lots of like short questions, you know. Yeah. Okay. I think we'll probably finish there. Yeah, that's good. And then, do I have you on Monday?
Yeah.
In the morning?
I think you changed the schedule.
It changed. Yeah. When do I?